everyone. I hope you are finished your tutorial 5.2. So this lesson I want to continue the tutorial 5.2, and I also give you all the answer, including the objective and also the structure question. Okay, so from here you need to refer is a PowerPoint. Then I show you in PowerPoint. Okay, come we start with the objective first. So from here everyone, you can check your answer. There's a question 1 until question 23. All the objective answer is here. If you still cannot understand the answer, why you get this one answer and you're different with my answer, then you can PM me. You can ask about which one question, then you just snap photo, then you show me in Telegram, then I will explain for you. Okay, so hopefully you check it. Okay, then we go to the structure question. Okay, let's see the structure question. They got 3 different rays, P, Q, and R. Okay, now they emitting from the radioactive substance. The following, they show the characteristic. Okay, let's see the characteristic. Okay, first one, they say, first one, P is unchanged for the deflection for the gold leaf. Q also unchanged. Then R, they got decreases. That means the deflection gold leaf, they got decreases. Okay, then the spark. Okay, P is no spark for the spark counter. Q also no spark. Then the R, they produce the spark. Okay, now you see the track. When we see the track, then we know which one particle already. This one, the track is not continuous. Then this one is bending. Then this one is a straight. So the last one is a penetrating power. A few of the lead, they will absorb significant amount of it. Then this one stopped by the aluminium. Then this one stopped by the paper. So it's very clear which one is alpha. The R should be the alpha, Q should be the beta, then the P should be the gamma. So let's see the first question. Okay, they say based on the table above, state the nature characteristic of the ray. Remember the nature? Okay, refer the P. P is what? P is a gamma, is it? So the nature, we call it as a electromagnetic wave. Okay, how about the Q? Okay, Q, you refer the paper just now. Okay, Q actually is a beta, is it? Another words for the beta, we call it fast moving electron. So you remember the definition, we can say this one as a definition. Okay, which one ray has the strongest penetrating power? Sure is a gamma ray, is it? So from here you can say about gamma ray. You also can say about which one ray? There's a ray P. Okay, depend for yours. Okay, now we go and see the C. Explain why the ray, the R can produce the spark in spark counter. Okay, so from here we see that from the spark counter. Okay, so they say, okay, normally the spark counter, there's a form because of ionization, is it? Okay, later I show the next thing. Let me check a while first. Okay, now we're going to see the explain why the ray P can produce the spark in the spark counter. Okay, remember how come got spark counter? Because of ionization, is it? So that means when they got alpha particle, okay, just pass by there, they will easier to ionize because of the high ionization. So that's why they will ionize with the positive ion and negative ion. So that's why you can see about the spark to produce, okay, because of the collision. So from here we just answer why ray R. Ray R is what? Ray R is alpha, so they can produce the spark in the spark counter. The reason is because the ray R is a high ionization power. Okay, so strong in ionization power. Okay, then we continue with the ray P and Q. P and Q is a gamma and also beta. Why cannot detect by the gold leaf electroscope? Okay, remember gold leaf electroscope just can detect the alpha. So in straightforward answer, P and Q actually is a low ionization power. So they cannot detect by the gold leaf electroscope. Okay, both have the weak ionization power. Okay, explain why the ray R produce a thick and straight track in cloud chamber. What they produce, there's a straight. After that, in the cloud chamber, remember the cloud chamber, there's a misty track. Okay, ray R is alpha, is it? So why they can produce a straight line. So now we straightforward go to answer. Why they got straight line? Why the beta is a curved line when the gamma is a continuous line? The reason is because of the mass, is it? The ray P is a alpha. Alpha, the mass is higher. Then you can say denser lah. So if denser, that means they're not easy to bending. Okay, not easy to be bending. So that's why they will collide with the A molecule. After that, they produce the track, the straight track. Okay, so from here you can say about the alpha particle, they're denser. Then some more of the collision because of the inertia, not easier to be changes the position, so they will collide. So from here we just write the answer. There's a more denser and not easily deflected. So that's why they will produce a straight line. After that, produce the highest ionization power. So from here, we no need to explain about ionization. We just say why they produce the straight track. So just about the denser. Okay, so we finish for this one question. Then continue. Okay, 25. Uranium decay series. Okay, they do so many times of the decay. So until the last one is Ra. Okay, so this one is a diagram for the equation. So from here, name the ray or particle emit when TH, okay, 2, 3, 4, this one 2, 3, 4, 90, decay to the PA, 2, 3, 4, 91. So we from here, you see the nuclear number never changes anything, just the proton number. So we know they change how many? 1 only, is it? So that one, the proton number should be the beta. Okay, so name the ray. The name you can say about the beta. You also can say fast moving electron. Okay, so this one's a beta particle. Okay, we continue with B. Can you state a pair of the isotope? Isotope, remember, same proton number, different with the nuclear number. So we find it which one is the same proton number. Okay, first one we find it uranium. This one uranium 92. This part also 92. So this one is a first pair of the isotope. We still got second pair. Can you see the TH? TH is 90. This one also 90. Okay, so now we can say they got two pair lah. But the question they just one pair. So either one you just can mention. So from here you can write the first pair uranium, or you can write about the thorium. Okay, either one also correct. Okay, then we go and see the half-life of the PA. Okay, PA 91, 6.7 hours, and initial has a mass 32 gram. So what is mean by half-life? So remember the half-life, just now I told you, half-life is a time taken for the activity to fall become half of the original activity. Okay, what activity? The activity is a radiation. Okay, now we're going to see the full definition. Time taken for the activity of radioactive reduced to half of the original activity. So this activity, we call it radioactive activity lah. So when the fall become half, so we take the time. That one, the time we call it, there's a half-life. Okay, now what is the mass of the PA after 33.5 hours? So one half-life is 6.7. Now I say 33.5. Okay, I need to find out inside got how many half-life first. Okay, after I find it got how many half-life, then I need to using 32 gram. 32 gram is the initial. Okay, after the half-life, I don't know how many times I need to count first. Then I need to find out there's still got how many will be left it. Okay, what is the time after 32.5? Okay, now we're going to start. We do the half-life first. We find it, we got how many half-life in 33.5 hours. So we need to take 33.5 hours over 6.7, because 6.7 is 1 times. So I need to know 33.5 hours inside is how many times of the half-life. So when I do the calculation, I find it, there is 5 times. That means you need to divide by 2, divide by 2, divide by 2, 5 times. Then I need to know the PA, finally the left, how many? Still not yet decayed. So from here, 32 divided by 2, divided by 2, divided by 2, okay, 5 times. Finally, just left 1 gram. Okay, after 33.5 hours, 32 gram decay until left 1 gram. So that means 31 gram already decay. So finally, just left 1 gram, not yet decay. So this one answer, you just write 1 gram. Okay, we don't have any formula to do this one declaration. So you just show like this only. You just show 32 arrow, 16 arrow, 18 arrow, 4, then until last, then you stop. Okay, so this one is easier for you to understand. We don't need to create the equation. Okay, next we go to the following question. Okay, let's see this part. They got 2 diagrams. They show about the rate of decay of the radioactive substance. First one is a fluorine. Okay, 22. Another one is a sodium, 24. Okay, now we're going to see the first one is y-axis, activity count per minute. X-axis is a decay time. There's a second. This one also same. Okay, now we see the starting. Starting bowl is 2000. Okay, what's the difference now? The difference is the time decay. Okay, let's see the fluorine. Fluorine is count by 2, 4, 6, 8, 10, 12, and 14. This one is a 1, 2, 3, 4. Okay, let me check about the half-life. 2000 when become half. Okay, so it's 1000. Okay, time taken is how long? 4 seconds. That means they take 4 seconds from 2000 drop until 1000. Okay, let's see the sodium. Sodium is from the 2000 drop until 1000. They just take 1 second. So which one faster to decay? Should be the sodium. Sodium 1 second, they can decay become half. Then the fluorine, you need to take 4 seconds. So that means the sodium must be faster to decay finish. Okay? So now you're going to see the following question what they want. Based on the decay curve, fluorine and also the sodium. So state the common characteristic of the change. Okay, they want change in activity. What is the common characteristic for these 2 diagrams about the change activity? Okay, relation with the time. Okay, now we're going to see the diagram. What is the characteristic is a common one. Okay, when change activity, we never say initial. Initial, I know both also 2000. Okay, I want to know when changing. When changing, do this one activity. Both diagram, what should be the similarity? Okay, I just find it. First diagram, when they drop, become half, the time taken is a 4. Okay, when they drop to the 500, can you see? When they drop become 500 half again, they become 8. So that means every time the changes is a 4 second. Okay, so now we go to see the sodium. Sodium 1000 is a 1 second, is it? So 1000, I want to drop again, become half, that's a 500. How long? The time taken is 2 seconds. So I also can say about sodium, every time they drop become half, then the half-life must be the same. Okay? So from here we can conclude what is a similarity. The similarity is in both diagrams, when they drop become half, or you can say the half-life must be constant. Okay, every time the half-life must be constant in both diagrams. I never say both diagrams is the same. I just say the fluorine, when they become drop half, the half-life must be constant. The sodium also same. When they drop become half, the time taken also must be constant. So this one is a common characteristic. Okay, see how to write it. Okay, the number of activity reduces. Number of activity reduces by half for a fixed period of the time. Okay, your period for the half-life must be fixed. Okay, after that, the number of activity reduce. So when you just reduce by the half of the fixed period of the time. Okay, reduce become half, your period must be the same. Okay, so that's why this one is a fixed. This one just one of the same characteristic. The rest also different. Okay, the next one, complete the table below. Okay, let's see the decay time. decay time for the foreign, 2000 is a 0, okay, 1000 is a 4, 800 is a 500 is a 8. So we recall back. So 2000 is 0, 1000 become 4, 1000 become 4. Okay, 500 is 8. Okay, 8 seconds. So we can write here. Okay, 250, they don't want 500, they want 250. So we continue lah with the 250. We're going to find out. Okay, there's a 12. 250 is a 12. So you can see the sequence here. Become 4 plus 4, then plus 4 some more. So become 12. So we see the sodium. You can refer your notes. The sodium is when starting is a 0, 1. So that means we know the half-life is a 1. When the half again become 2, half again should be 3. So that means the half-life must be the fixed. Okay, now what happened to the activity of the fluorine after every 4 seconds? Every 4 seconds, what happened? The activity how? The activity will drop, become half. Agree? Every 4 seconds, they drop, become half. So we just write it reduced by half. Okay, how about the sodium? Sodium after every 1 second also same, is it? Also reduced by half. Okay, then we go to the C. When the fluorine 22 decay, it produce, okay, beta particle. The question already tell you there's a beta particle and also neon. Okay, so what is a beta particle? So we understood lah. Beta particle, the meaning is fast moving electron. Okay, now we go to complete the following equation for the decay of the fluorine. So just now told you neon. Okay, after that this one is a beta, is it? So we write the beta first. Beta is electron. So you just write electron. After that up is a 0. Then down is a -1. If down is a -1 means Ne. Here must be 10. This one no changes lah, 22. Okay, down should be 10 because your final you need to put -1 for the beta. Okay, so this one is the structure question. So everyone, so this one is what I want to show. That is a tutorial 5.2. So structure just a little bit question only. So the objective is more lah than 23 question. So make sure you understand the question. No calculation, just simple only lah for the isotope or the nuclear number and the proton number. So hopefully you understand. So the coming soon should be the 5.3 lah. The 5.3 is a simple one. They're just one of the concept you need to memorize. Okay, about the radiation, what's the function, then just a short only. Okay, no calculation, concept only. Then I will straightforward 5.3 and 5.4 join together. Okay, if the time enough, then the tutorial should be separate lah. Then 5.3 and 5.4 we join together for the coming lesson. Okay, hopefully you will understand. If not understand, you can PM me and ask about the question. Okay, so every student, thank you for your watching.